G'day team, Adam Cogan here from NSW TV. Welcome to the December 2021 .NET user group. This is the last one for the year, and hopefully you'll have a great night tonight. We have great speakers and some great news. We did have lots of people telling us they were coming along tonight, and then we got a new version of coronavirus, Omicron. I usually like new versions of things, just not coronavirus. So yeah, so that's frightened us. We got a few hundred cases, and things have quietened down very, very quickly. But hopefully we will see more of you in the new year. Welcome to all our user groups around. I know Brisbane are busy up there in Melbourne, so that's good. Newcastle, well, we had a rogue guy that had Omicron turn up to a nightclub and gave it to a couple hundred people, so I guess the Newcastle newies are all at home. So welcome to everyone and everyone on the web. And I think it is time for the SSW Tech News. G'day team, Adam Cogan here from SSW TV. Tonight for our .NET user group we have JK as our speaker. He'll be speaking about common mistakes in EF Core. He is the man we go to when we have any data access issues at SSW, so hopefully you'll find this great. You know, Entity Framework works so well until things get complicated and you have performance problems. And JK always has a better answer than just execute it in raw SQL and bypass Entity Framework. So hopefully you'll enjoy that presentation. Now let's jump into the first piece of news tonight, which is related to JK's session, and that is Entity Framework Core 6. What's in this, our favorite data access library? Well, there's a long summary here. I'll just quickly run through the main parts. The headline is they've done heaps of work with Cosmos DB. Entity Framework works, I think we can say, pretty much perfectly for SQL Server. Azure Cosmos DB, there is a few things that people have been complaining about, and that's the main thing. It's summarized quite nicely here. Here is the big feature, and I might just jump over here just to quickly summarize this. He essentially talks about, imagine that you have a scenario here where you're pulling data for blog posts and you're nesting and then you're getting some more stuff, and these queries are performing poorly. So if those queries are performing poorly, what do? What is if you know that you need to bypass Entity Framework, what's the best thing to do? Well, let's go and see what he says. I'll just skip ahead.
Recreate our link query. So I happen to know that this link query right now is too complex to be translated out of the box, which happens in some edge cases. But what we added in EF Core 6 is the ability to use raw SQL. So we can hit those edge cases and make them work. So I'm going to go to my DB context and I'm going to add a little snippet of code here that basically has a SQL statement.
So I'll just pause it there for a second. He's essentially saying the one thing that people wanted was a get out of jail free card. You don't need to use this very often, and when you do, you should make sure you document it and have good reasons for doing this. But that's the SQL he wants to inject in and bypass.
That's doing the same thing that Link did, which is filtering the blogs based on the tag and then projecting the posts based on the tag. And then it has a wrapper method that takes any tag and projects it onto that SQL. So very straightforward. From SQL raw is what we use. We basically marry the tag to the SQL and we say to list async. So let's go back to our program and let's change this to await context get logs with tag filter. The tag filter is going to be second, and I'm going to go ahead and run that. let it execute this query. Let me make sure it's running. And
bingo, there you go, and it worked. So that is that option being added. What else did they add into EF Core other than the Cosmos support? They added compiled models. So this was a request because sometimes your models get very large. And when you get very large, they have a nice little blog post here. I might quickly show that to you. But essentially, when your models get large, let's look at the graph. Oh, they explain here why. Why is it slow? What is it doing? What are all those things that happen in your startup? And essentially, as your models get bigger and bigger, more properties, more relationships, more fields, it's bigger and bigger, you'll notice that the startup time gets slower and slower. Okay, so it's a fairly linear relationship. What's their fix? Their fix is not to do it on startup. In code, do it at dev time. So they're saying basically run this command here, or if you're using a NuGet package manager, you can run this command here instead. And then in your code, in your options configuration, add this, and then that will be done on the developer's time rather than the startup each time. So that's a useful thing. What else have they added to Entity Framework? They've added this configure conventions. So if you want consistency, they've given an example of here, if you want 2,000 characters on in your strings, how would you make that consistent everywhere? Well, they've got, they summarize it here, and they talk how you would do that. For example, here's their example. Max length of all string properties can be configured to be 1024. And you would add this in your C#. If you wanted all your date times to be 64-bit integers, you would add this. And for example, if you wanted your booleans to be 0, 1 and extensible, you could add this. So that's how you're doing that. What else have they added? Well, they've added migration bundles. So this is an interesting one. If you have a large project and you're splitting it up and there's lots of pieces of your project, then you can use this. So for example, we have some large projects. They don't want the monolith story. They want it all split up, but you want to have one data context. So you can split this guy out and have it in a separate project. So that's what that's about. There's definitely a few clients that we already need that for, so that's great. Performance, there's stuff here about how it's improved the performance, and my fellow regional director Julie Lerman has a nice video on that, so you can learn all about that. Temporal tables, I think this is my favorite part of the whole story, and we've talked about this before, but when you have a record that is changed in a database and it is not what you expect, you want to know who changed that. Now you can use some hacks, you can put some triggers in SQL Server, you can put some extra code in your web API, but this temporal table solution is the way that is the best story going forward. Now, everybody's talking about GraphQL. For some people, they prefer it a lot more than REST, and that's the same story inside SSW as well. And there's some videos on that as well. So anyway, there's heaps and heaps of stuff, and I think you're going to be pretty happy with Entity Framework Core 6. Notice that it's called EF Core 6, and they haven't dropped Core even though we have .NET 6. So the naming is different, and that's been talked about as well. So let's jump in ahead and what other news do we have? Well, likewise, we have had a major shift, not to just .NET 6, but also to Blazor. I would say Blazor is becoming, it's probably the most popular front-end technology we're using here. It's more popular than Angular and React, I think, or it's certainly level pegging. And now the tooling for that has not been as rich. So let's see what they've given us here. So here we've got a red line under the JSON serializer. You see that, you click on the little light bulb, you click using system text JSON, and it will put in the using statement for you, okay? We've had that for a long time. It's good that that's come to Blazor. Let's just say that we have a chunk of code and we want to refactor that. We want to pick that code up and throw it from the front end to the back end. You could select the text. You can then click this light bulb, and say extract blocks to code behind. You'll see what it is, and then boom, it's moved. This one is probably the only one that we needed to have, and that is when we're looking at a method and we want to go to definition, we now have that. I think some people would call that a bug fix. All right, was so needed. Anyway, so there's lots of other things here. Oh, I think that you'll definitely want to know about hot reload. So let's just say we've got code here and we've got it, we're viewing it over here. We can just make the code change. Here we can make the code change here. Then you'll see the code change is made. We click up here and we click the little hot reload button, and you'll see that changed over there. Okay, so that's the hot reload working, quite nice. And the default colors. So in the old days, let me just zoom that in a touch. In the old days, it would look on the left. They've got this weird highlighting. In the new world, it looks neater. All right, so that's the story there. And lots more stuff. Now, next piece of news. I want to show you this GitHub code search. I think this is going to be really important. We're doing a lot of projects on GitHub. I'm sure you guys are too. So let's have a look at what they've added for us.
Your company's code and the open source code you depend on. It's cool to search the world's code, but probably what's more useful is searching code relevant to you. And that's why we created this scope dropdown. If I click on this scope dropdown, I can choose to search code within just my organization, or code that I personally own, or I can narrow down to a specific repository. But the most powerful feature is to create a custom scope that lets me search a set of repositories that are relevant to me. I've already done this for my team, which is called the Blackbird team. So I'm going to narrow down to code relevant to my team. And now let's do a search. I'll just start by typing part of a file name, for example, .sql, and immediately find a bunch of SQL files as suggestions. Or I could type part of a symbol that I remember and immediately see a bunch of symbol suggestions. Let's try jumping straight to the definition of this class. And now you can see the second really powerful feature of the new code search experience, code navigation. So here we're in the code viewer, and you can see we have a bunch of extra symbol information, which is helping us quickly whip around our code base and navigate. For example, let's look at this function, inc contents loaded. I can, in a single click, search for where this function's being used. Here's the definition, and here's where it's being called. Let's jump and see more. And now we can see it's being called within this other function called lowercase content within a struct called lazy content. I hope you can see how the tight integration between search and code navigation allows us to not only get to the code we need to, but also follow the path to find exactly how the code works. Our code navigation is actually even better. We can also, for example, jump on one of these imports and jump straight to the definition, even if it's in another file. And in some languages, we even support jump to definition across repositories, which is super powerful.
All right, I think that gives you a bit of an idea what they're doing there. I think that's really exciting. It's great to have a lot of code at your disposal, but you've got to be able to find it nice and easily. And I think they've done some great work there, and I think that we'll enjoy using that. Of course, I'll be interested to know if you guys think that's cool. Definitely put a comment down there for the ones that you're finding cool or you think are not cool or missing features. So let's talk about GitHub Actions. So we've spent a lot of time over the years in Azure pipelines, build and release. We are doing more and more with GitHub Actions these days. Now, we want reuse. If you have a look at this example here, so these steps here, this is an action, and what we can do now is we can move that chunk into a separate action, throw it into the GitHub marketplace, and then call it like this. So now we can get a lot more reuse than we could have before, and we can reuse our own actions. So hopefully you'll like that. There is also this, where we can move steps. Okay, so let's have a look at this, where we've got these steps here. We can move these steps into their own workflow file. Okay, a YAML file here, and you can move that there. And so this code is a lot simpler, and we've moved that into its own file. So hopefully you like that. There's lots of other things. This one, what's this one? This is if you have a workflow. So if you have an action that you deploy and it deploys to staging, you might not want the person that can deploy to staging to be the person who is got the permissions to deploy to production. So you can you can have separate permissions for that. So that's all the work, and there's a lot of work being done on GitHub Actions. Okay, let's look at what else we have. What other news do we have? I found this one interesting. Microsoft Teams has definitely been one of the big success stories in Microsoft. And of course, clients are asking, hey, could we embed the ability to call in our app? And the answer has been no. You try to find some hacky clicks to open up Teams and stuff. But what if you just want to embed that in your own application? It's nothing to do with Teams. We want them to use just our app. So we can have a look at this and tell me what you think of this.
To tell you that the foundational capabilities you mentioned with voice, video, chat, SMS, and PSTN calling are generally available this month.
That's really great news, especially given the interest that we've seen in the service from our last show. But how are you seeing this then being leveraged?
There's been an amazing response to Azure Communication Services across various industries. And this translates to millions of voice and video minutes and tens of millions of chat and SMS messages as many of you experiment with custom app communication experiences. One of my favorite use cases is from Norwegian company Lærdal Medical, who provide training and education products for life-saving and emergency medical care. They developed a CPR Link app that uses Azure Communication Services to connect their volunteers administering CPR with medical dispatchers via video streaming. So they can get in-the-moment, just-in-time expert feedback as they perform CPR to improve the quality of treatment and patient survival rates. They estimate the app will reduce CPR error and save thousands of lives every year.
And that's really a great example of real-time communications, and I'm sure we'll see even more examples now with the general availability of core services coming soon.
All right, so that gives you a bit of an idea. The Norwegians showing us great examples again. They do amazing stuff. They always seem to be popping up. Let's move on to the next piece of news. And imagine a client comes to you and says, all right, I need that record, that invoice, that vaccination, whatever. I need it put there and it cannot be changed. Throwing it into a database doesn't do the job. You can never trust who can change it. You need some method that it can be put there and it cannot be moved. Let's just say the legislation is it must stay there for 7 years. Well, now we have immutable storage. And this Azure Blob Storage option gives you the capability to store data in a write once, read many. That's known as a worm state. Okay, so that is essential for some compliance. Obviously, the big companies need this for some governance or legislation purposes. So that's immutable storage. We can now answer yes to that question. Moving on, next piece of news, bit of fun news, Notepad. I've been using this Notepad for, I don't know, 20-something, 25 years, is it? And they've never upgraded it, even though it's been there the whole time. We can't even go File Recents or Tools Options. It's ridiculous. But anyway, we now have it, and it now looks good. And what do you think the most important feature and how you can tell if you have this? You won't have it yet. It's rolling out in this Windows update coming. you will see search. See the search? So when you search, you have this up-down, okay, rather than the crummy search. So I've always been telling people never use Notepad. It's kind of one of the first things you learn when you join SSW. Don't use Notepad. There's so many good alternatives. Notepad++, VS Code, etc., etc. Anyway, I don't have they have a better response now if they've got this. All right, let's move on to our last piece of news. And our last piece of news, I'm not sure if it's fair dinkum news, but Apple accelerates work on their car project. They're going to give us an automation vehicle. And I'm not talking about Tesla automation. I'm talking about a car without a steering wheel that looks like this. Now, I use autopilot in Tesla a lot, and it's pretty good, but it makes plenty of mistakes. There's no way in the world I'm getting in one of these things without somebody on a steering wheel. But they think this is going to work. Well, I think it would be good if everybody's in them. That would certainly work. But when you've got randoms driving around, I'm not sure it's going to be as good. But anyway, maybe you might disagree. Throw a comment down there and tell me if you would buy this today, if it existed. If you'd buy it in 5 years' time, I don't think I'll be buying it. Anyway, so hopefully you've enjoyed that. I look forward to seeing you guys in the new year, and I will see you in the next one. Welcome everyone to the .NET User Group. Tonight we have JK. He's going to be talking about common mistakes in EF Core. He is the man we go to when we have any data access issues, any performance problems with Entity Framework. And I'm going to hand you over to JK.
Hi everyone, I'm glad to be here. I have actually a live audience with me, and not just one person, but more than 10 people, which is amazing. I think this is the second in-person talk that I have done this year, and I'm really happy to be here. Now, I am going to share my screen. Sorry. All right, I think I'll need... Adam, can you mute your Teams? I don't think I can. Apologies for technical issues. Give me a moment. Okay, we got everyone muted. All right, let's get started. So, hi everyone, and welcome to the Brisbane Full Stack User Group, or Sydney User Group, or Melbourne, or Newcastle, from wherever you're coming from. Today, I'm going to present about common mistakes in EF Core. Not only what are those mistakes, but also the impact of the mistakes and how you can fix it and how it's going to be compared with the non-fixed one. So I am Jernej Kavka. I am a solution architect at SSW. You have a couple of socials. You can follow me at Twitter, LinkedIn, GitHub. I'm organizer of several different events. One is Brisbane Full Stack User Group, then the Global AI, the podcast, the APEC AI User Group, and several events like the AI Hack Day. So lots of different events. I don't even remember all of them, which is sometimes fun. And also I do .NET Core and EF Core day to day. That's my expertise, and as enthusiastically, I am dabbling in cognitive services and ML.NET. So if you go to Discord official for ML.NET, you can find me there talking about ML.NET. So we have an app for taking rewards at our SSW events. You can download via this QR code. And at the end, I'm going to show you a QR code where you can scan it for this particular presentation, and you'll be able to win some prizes. I'll keep the slide just for a few more seconds. All right. And today what we're going to talk about is a little bit about the EF Core, a couple of competitors, just touch on that, how I'm going to show you the results, how I have determined that what we're doing is terrible and how the new changes makes it better. And then we're going to go what I call the 7 deadly sins. So these are the things that I have seen at client work, sometimes even at our own projects, but a lot of also on GitHub public projects, and how to fix them. And at the end, I'm going to just do a rapid fire of best practices that I didn't really have time to talk more about them. So, okay. When we're trying to start with a project and we're thinking about what database we want to use and what ORM, we are basically faced with a lot of different decisions. So we have SQL Server, we have Cosmos DB, Postgres, we have MySQL and many more. So there's already a lot of decisions to do over there. And once we decide that, we have also various different ORMs, everywhere from EF Core, which is really good because it supports lots of different database engines. Then we have Dapper, which you can use directly with SQL Server, or you can hook it up with EF Core and use SQL Server via EF Core. Martin, if you use Postgres, it's a pretty nice library. It's almost like EF Core, just tiny bits simplified, but hopefully after this, I'm going to convince it to switch to EF Core. Cosmos DB SDK. Now, before EF Core 6, I would have Cosmos DB SDK instead of EF Core, but with EF Core 6, my recommendation might actually change. I haven't used it yet, but it looks very promising. And there's a couple of other ORMs as well. I think it's Hibernate and a couple of other things. Anyways, so the reason why I pick EF Core and why I recommend personally EF Core especially for relational databases is it's a great balance between features, flexibility, and performance. Now, you can have built-in migrations for almost all of the database engines, so you don't have to write that on your own. You have DB scanfolding, so you can do code first with the database first. You end up with code first code, even though you basically scanfold a database. And lots of other tooling. There's a lot of utilities available for EF Core. And that gives you quite a bit of flexibility. Like you can switch to SQL Server, SQLite, Postgres, Cosmos DB. It just gives you the opportunity to just say, hey, we're going to first go SQL Server, and maybe later we're going to switch. And you don't have to rewrite the entire application. You don't need to write repository patterns in order to be able to switch to a different database. And that being said, with all of these features, and Adam mentioned temporal tables and a couple of other things, we don't get as much performance sacrifice as we used to. In a lot of cases, especially with EF Core, that they are even promising as good performance as Dapper, which usually have been the fallback if EF Core wasn't working fast enough. So it's really exciting times where we're almost having now all of the ticks green, whereas previously we had a bit harder choice where half of the ticks were green, half of the ticks were red, and then they say, yeah, enough green ticks are for this project. All right. Now, this talk is going to talk about a lot about pain and how to avoid that pain. And what I found is that a lot of issues that people had with EF Core, or they didn't know they had issues with EF Core, are easily fixed. And often that came with simpler code than the one they have written, simply because they didn't know that you could do that. And in order to quantify what all of the things they're going to show, I have done benchmarks for all of the examples, the bad as well as good. I'll have you linked a GitHub repo where there's a lot more cases that goes even more in depth for performance testing. And I also recommend you to do this yourself when you want to improve performance of SQL queries. Do benchmarks, because sometimes you may end up with worse result, even though it looks like you have written a more performant code. And I will share you some of the horrors I have seen. And hopefully you will appreciate the amount of performance will go back by just doing small changes, as well as stability improvements to the SQL Server as well as the ASP.NET Core application. All right, so what I did for benchmarks is I used two different tools. One is the benchmark.net. That one is used primarily for memory consumption, because there were 2 or 3 tests where I noticed that the memory went out of control, and I wanted to show you, hey, avoid these things because it's going to destroy your memory. Now, most of the other things are going to be more CPU bound. So I'm using Bombardier, which is a simple load testing tool for individual URLs. And the reason for why I'm preferring this over benchmark.net is because you're getting different results if you're trying to hit one URL constantly one by one, opposed to say five threads at the same time, or 12 or 24. You're getting you can get massively different results, and that's why I'm actually relying more on the results of Bombardier, because this, I believe, represents more closely how the application is going to behave, opposed to benchmark.net, which is testing it multiple times, but only one request at a time. All right. And also, I am fully aware that you're probably gonna want to try this yourself, and then you'll say, "Hey, I do not get the same results." Well, here is my setup, a testing setup. So I use .NET 6 and EF Core 6, and in order to remove the variables of latency, transfer, and things like that, emulating SAFime on Azure, without needing to pay thousands of dollars for the amount of performance I'm going to use, I'm using my beefy desktop instead, which is a Ryzen 9 5900X. And the reason why it's really good is because it has 12 cores, which translate to 24 threads. So this represents a quite beefy Azure machine. So if this machine is struggling, the machine on Azure is probably going to struggle as well. You can put multiple machines, well, you can spin up multiple machines. I cannot do that at home. But rule of thumb, sometimes it's better to optimize than trying to scale up, especially when we're talking about the simple things, fixes, as we're talking about today. And the last metric that you might want to know is I'm using 32 gigabytes of RAM. All right, so the test data is from this URL over here. It's a SQL Server demo database. It's about sales and products, employees and customers. And the reason why I have picked this one opposed to another popular database called Northwind is because this database is very simple, but has a lot of data. So if you mess up with this database, you're going to royally mess up on a bigger database, more complicated database. So this is a good benchmark to see, am I doing something horribly wrong? And if yes, it's also a good database to verify your fixes. All right, so let's get started with 7 deadly sins. So the first deadly sin, which I'm just going to mention because I hope it's quite obvious to everyone, is if you don't filter down the amount of rows you're getting from SQL Server, you're going to have a bad time. If you download the entire table, you'll download a lot of data. So hopefully that is obvious. But the next one might not be as obvious. So casting from iQueryable to IEnumerable. So I'm going to show you a bit of details of why this is a problem and the horrifying results of that ever happening. Then why you should use S-node tracking. This is one of the most common things that I see not being used. So hopefully after this, you're going to start to use it. Explicit joints. This one is quite tricky because a lot of people are kind of aware of them, but not really. And some of them that are aware don't think about whether doing explicit joints or implicit joints have a massive difference. And I'm going to show you that it has a massive difference. Then get only columns you need. That's going to be bit combined with the explicit joints. The less column you request, the faster the things are going to be. Simple. Pagination. This is somewhat frequently used in the projects and very frequently done wrong. So we're going to check pagination. And lastly, non-cancelable queries. So if you worry about denial of service or a huge bump of users coming to your server, you definitely want to look into that. All right, finally, there is usually the phrase that's called, how bad can it be? Generally speaking, you don't want an answer for that. And it's usually said by everyone who just about are going to discover a horrifying truth. So try not to say that. Okay, so how bad can it be when we do counting? Well, we can have someone doing something like this. You're like, okay, we're doing two lists, right? We don't want an entire table. That's easy to spot, right? What about this one? Now we're casting the sales property over there is IDB set. We're casting it to IEnumerable, right? That, okay, something seems to be wrong with IEnumerable, right? But it's not as obvious, right? But then even more common, what we have is we're having a method that is returning IEnumerable. That is very common pattern where you don't even know that you're using IEnumerable behind the scenes. And you're like, why is everything so slow? And the reason for this is they're all the same. So when you do all of them, it's like you're doing two lists before you even starting counting. And the reason for this is what happens is when you do the HTTP request and then you hit the query, here we have the, if I get the mouse here, we have the sales DB context and we cast it to IEnumerable. What happens is EF core only evaluates the query up to IEnumerable. What that means is it's just going to select everything. And to make things worse, once we get the results, it's going to pass all of the data from the database, and it's going to add all of the tracking to all of the rows, to all of the columns, and then it's going to count all of the rows that it got, all of the data, and then it's going to just dump everything into garbage collector, and then garbage collector has a bad day. And how to fix it? Well, change IEnumerable to iQueryable. It's as simple as that. But you would, and here is just, the difference here is once we get to evaluate entire query, we're getting select count from sales. So now we're getting a single integer back. That integer is not tracked because it's a singular integer, and we can then return the results. There's no there's almost no parsing. There's no tracking. You just get the result and you return the result. Now, some of you know link. What is important to understand is that EF core link is not the same as IEnumerable. You can remember that IEnumerable is almost always in memory, whereas iQueryable the source can be anywhere. It could be in memory, it could be on SQL Server, it could be on Cosmos DB, it could be even block storages, or as any kind of sources. And it works a bit different than the standard link. If you imagine the enumerable will always execute everything the way you specify, always in the exact same order, whereas iQueryable could flip everything around. You're not guaranteed that the operation that you put will actually be the operation that you have put in. The easiest example of that would be, for instance, if you do where clause and then first of the default, it will the where clause and the first of default will actually be merged in iQueryable. That's the simplest example of that. All right, so what is the impact of that? Shouldn't be too much of an impact, right? It's about 1 million times more memory consumption. So we're getting 2 gigabytes of memory consumption when we're trying to count 7 million records. Now, imagine that what happens to the server when you're starting to get a couple of requests and say that that is happening on pagination, maybe even on the front page. This is going to destroy a server. This is one request, 2 gigabytes. But if you're using iQueryable, it only gets 6 kilobytes. And the worst thing about this is a problem that is going to get bigger and bigger over time because the tables are growing. So at the beginning, when you start developing, you maybe have 100 elements in your table, and you don't notice this performance issue. A year later, all of a sudden, people are complaining that the flow is getting slower and slower, but you're like, I haven't changed anything. Well, that's INumerable across all of that. And if you don't care about memory, it's 64 times faster, which is a full 3.5 seconds faster in this particular case. So that is massive. And just remember here, we have 57 seconds on average for one request. And this is doing request one at a time. And this is important because I have done load test for this. So for instance, when we did the load test and I used 5 threads, they're trying to gently ask the server, can you give me the results? And it only asked for another request after the original one was finished. And we got 33 seconds on average, the response time. That went from 3.6 seconds to 33 seconds. So this is why it's important to do load testing and see how well your link queries actually are going to hold on in real world. So this is if you use INumerable. If you use iQueryable, we have 128 milliseconds. Although what I notice is that the reason why we're getting that much performance is because SQL Server was starting to get the problem, not the ISP.NET Core. So if I bump SQL Server, we would get even better results. Whereas in the upper result, we basically trashed our CPU as well as our RAM. Our app is completely unresponsive in the load test. Well, here it just breezily handles it. So this is 260 times faster. Amazing, isn't it? Also, the reason why I used only 5 threads on a 24-thread CPU is because 5 threads were enough to trash my computer with the above query. Well, down below, I could use 24 threads and it would handle it easily. I wanted to have comparable results, so I just stuck with 5 threads. We're going to have one that's going to have a lot more threads. So what about S-node tracking? So why this is important is it excludes the tracking on entities. So the entities are kind of like read-only results. it uses less memory, it uses less CPU usage, and you want to use that when you don't want to update or delete your entities. Do not use that if you want to update, because if you use the dbcontext.update, you're going to update the entire entity, even if only one property has changed. So try to avoid that. So what happens behind the scenes? So by default, tracking is enabled. So when EF Core generates the query, sends the query to a SQL Server responds back with the results, and then we do a parse and map, and it adds all of the tracking properties. Now that happens for every single row, for every single columns. It adds an additional property to the class. So that is where the CPU and memory cost comes from. Now, if we do as no tracking, the process is the same. We just cut off this middleman. So what's the impact? Well, here we have the results was about a few thousand or few 100,000 cells, just to give you the size differences between the count and this one. And the difference is 4 times less memory. Now, if your results are fewer, like just 10, you won't notice as much the memory consumption, but on big queries, it will have huge impact results. It's also about 5 times faster. Now, in general, I found that you don't do these huge queries very often if you do things right. You probably will get about up to 33% performance gain when you're doing with small queries. But in extreme cases like this, you can get even higher than 5 times performance gain. And you can see it's 1.6 full 1.6 seconds faster. So it's not negligible. And also when we do performance comparison in load testing, we can see that it's 4 times faster, which is a little bit less than what we had previously. Previously, we had that single execution was 64 times faster, and then load test was how much was 240 times faster. Here we the single execution was 5 times faster, and the load test was 4 times faster. That's because we are hitting different bottlenecks. One was on SQL Server, and here I believe it's the here I think it's the CPU. So that's something to keep in mind. And this is why you want to do load tests. Now, the next one is explicit includes. Now, a lot of people love to do .include and includes the entire table. Now, that is fine if you need to also update what it's in the include. Sometimes you can get somewhat performant codes than doing separate queries that are trackable. But what often happens is that what developers do for read-only queries, then they sometimes forget that they no longer need to include those queries. So join tables are one of the more expensive SQL operations. And EF Core is not going to remove those. Even if you don't use that table, it's not going to remove it for you. So if you have forgotten to remove it, you're paying the price for it. And what also happens is you don't always want to have all of the columns of the included table. So what you can do, I'm here a bit combining implicit includes with select. So what you can do is rather than using include and then you include the table, what you can do is you can write your own select statement. You can map the data from the database into an object directly, and you can reference the table directly, the properties that you need. Now, the code, in theory, looks similar, and semantically speaking, it does the same thing. But the impact doesn't tell us that. So the impact when we load test is that it's 2.5 times faster. and I spent it like 2-3 hours to figure out if I did something wrong that I get so much faster query. But it turns out that explicit includes are just so much more expensive, and when you add select, it's just everything so much faster. So try to just get the data you need and don't use explicit joins. You'll get, I think this is nicer code in my opinion. You're basically getting all of the data you want. You're very explicit what you want. Everyone understands what you want to get, and you're getting better performance. So from my books, that's just plus. Now this one, pagination, is very, very interesting because a lot of people think it's really, really difficult to solve. And the reason why they think that is they know that, yeah, I can filter data, I can put it maybe on iQueryable, they may figure out the iQueryable part, but what they do next is they get all of the filtered data. At least it's filtered, it's not getting everything from the database, but what they don't do is pagination at this stage. And the reason why they get all of the data, all of the filtered data, is because they want to count them. And then they put the take and skip, which is used for pagination, to then do in-memory pagination. And then they drop a lot of data. And that's mostly because they don't know how to count accurate amount of result in an efficient manner. So here is an example of that code. So here we have, so on top we have the query, and here on this line, we're actually getting all of the filtered data. And then we do count in memory. And lastly, in memory, we skip some data, and we then take a snapshot of how much the page size is. Now, to fix this, what you can do is use iQueryable while you're working with the query. Before you're trying to get count and trying to apply pagination to it. What I also like is to make a select statement so you get a bit more efficient query as well. And what I do is then I use .count async on iQueryable. Now this is going to result into select count query. Now, don't get distracted by select statement. The select statement is not going to impact the count. So you don't have to worry about select. You don't have to worry about order by. Those that do not impact the count will not impact this line over here. So you don't have to worry about moving them around. And this is the main difference between INumerable and iQueryable. In iQueryable, the EF core can decide to just ignore the select statement. Yes. So the question was, there will be 2 SQL queries. Yeah. So this is the first one, count in SQL Server, and then the next one is the skip take, which is going to be executed as well on SQL Server. Now we're doing 2 queries, but these 2 queries are going to be significantly faster than having a single query. And here are some performance metrics. So I got about 1.35 seconds for the pagination I was doing in the load test. And when I ran this against the more optimized code, we got 18 times faster performance. Also keep in mind, this is also one candidate of memory issues because we're dialing way too much data. And we had one client where we started off with 100 licenses for the first couple of months. And then they say, okay, let's start to import data. And we ended up with millions of records. And there was one query that wasn't optimized, and we noticed it immediately. So try to do this pattern. It, like 99% of the time, it will work perfectly. And the last cardinal sin is the non-cancelable queries. Now, if you are worried about what happens with the server when it's overloaded, when it goes past the capacity of what the server can handle with, basically server has no other choice than start failing. You want to fail in such a way where basically you can actually recover from it, not in a way where the server is non-responsive for hours or even days, because it's still processing the thing that was overloaded with even hours or days after it happened. And that usually happens is because you haven't used cancelable queries. And what's the problem? So generally speaking, if you don't have cancelable queries, what happens is we have the HTTP request. We do a EF query, which is then sent to SQL Server. SQL Server processes that SQL query, all simple. And then what happens is that the client cancels the request. This is a very common thing that happens with denial of service. Now here, if you're not using cancelable token, few things can happen. It could happen that the .NET Core doesn't do anything because you haven't properly used cancellation token. It may cancel a few things because you're using the APIs where it says, hang on, the request has been canceled while we're still running. So it's a little bit of an unknown state over there once this happens. And once the result from SQL Server comes back, either because it's too overwhelmed and just say, I give up, or because it actually comes back with a result, there's two things that can happen. If the request is not canceled on the ASP.NET Core side, your code is going to continue running. Even though you don't have anyone to respond to, you still run it. And sometimes you want this. Like if you're saving some data and you want to save that data no matter what, maybe that's the right thing to do. But in a lot of cases, when you're trying to get read-only data, this is going to cause a massive issue. And this is what usually the denial service is trying to exploit, is trying to hit URLs that results in complicated queries to write on SQL Server, basically fire and forget. They fire, cancel the request, and fire again as fast as they can. And if the server doesn't cancel those requests, they get overwhelmed really, really quickly. And that's how you can get server offline for hours or even days. Alternatively, the requests have been canceled already, and the response from SQL Server is simply discarded. Now, how can you avoid that issue? So when you're using HTTP GET, HTTP POST, HTTP PUT, and other things in your controller, you can add cancellation token in the parameter. Usually it's the last one. I just call it CT because it's nice and short. And for most of the async operation, they accept cancellation token. So once the request is being canceled by the user or by any other thing that may happen, maybe something in the middle realizes, hey, you're under attack. I'm going to drop the connections that we determine to be the attackers. This is going to be triggered, and whatever methods you're using that accept cancellation tokens may actually cancel the current processing. So what that means is, if we look at the same example as before, we do the HTTP request, we send the query to the SQL Server. SQL Server is processing the request, but the difference here is when we get the cancel request back, the EF core is like, oh, wait, I am doing something on SQL Server right now. I have an active connection. I will let the SQL Server know, I don't need this anymore. Please cancel it. And what happens is that both your .NET Core, ASP.NET Core execution stops for that request, as well as SQL Server. if you forget to add the cancellation token on the SQL query, it's still going to continue on. So this is very important. Every single time you do toList async, every single time you do save changes async, first of default async, count async, use cancellation token. And rule of thumb, if there's an async option of a method, use it, especially if it has a cancellation token, because if you have a synchronous execution, even if you manage to kill the request on ISP.NET Core side, the SQL Server is still going to execute. And if you're under too high load or under attack, your SQL Server will start to give up and your entire website will be unresponsive. You'll need to start to restart your SQL Server. You'll need to restart your ISP.NET Core, and you'll need to manually manage the situation. Now, the difference here, this load test is going to be a little bit different. I'm using 12 cores for 12 threads to test this. I wanted to use 24 cores, but the bad example locked up my machine for an hour and did not get results back. I mean, it was still responsive, which is really good from Ryzen, but the load testing tool and the .NET Core application, the SQL Server were fully unresponsive for more than an hour, and I gave up. I didn't get results for that. So I did it for 12, and I did got the results after 5 minutes. So it took 10 seconds to respond. So basically the timeout was 1 second. It took 10 seconds from the time it was canceled to the time where the connection was actually closed by the server. So that means it was so busy with everything going on that it didn't even have the time to close the connection. Just to give you the scale of how bad things can go. Now, if we added cancellation token, on the other hand, oddly enough, we're actually getting twice as much performance. And what happens is, I think there was something else going on here as well, but in less than 40 seconds, I actually have my computer completely responsive, everything on 0% CPU. So basically, somebody could hammer my machine. Yes, it's not going to be responsive while they're going to overload my machine. They stop the attack. A minute later, we're all good. Whereas if you don't use cancellation token, you will have to crisis manage manually and hopefully recover quickly. You'll have to figure out how to recover from that, but that's why you have cancellation tokens. All right, so we have gone through the sins that I have seen in a lot of projects and what I really want everyone to know about and try to avoid. This here are a couple of best practices that I have found. I didn't have time to actually go too much into details. I'm going to show a little bit of the code, but just a few good to know things. So first off, there's things that I have seen, like they done toList on a result. First off, they did toList on getting a single employee. They could do .first.default and then say whether they got a result or not. But anyways, they did toList. And then at the end, they did .count and whether it's more than 0. So it's going to be either 0 or 1. If it's more than 1, there's a bigger problem. Now you can change this to just .any. And this is going to be the best performance you can get. Sometimes you can do .first.default. It's a similar performance as .any because we're talking about really small packages coming from SQL Server, really small amount of parsing and all that stuff. And I would recommend you to use first.default over any if you intend to use that data. If you just want to check if it exists, use .any. Another thing that I have seen quite horrible is some people didn't know how to actually do dynamic queries. So for instance, if you have something that is optional, some of them actually got all of the data ahead of time. The ones that weren't optional, they weren't dynamic. And then they did a if statement, and then they filtered those optional queries. You don't have to do that. You can actually build up queries in code before sending it to SQL Server, and that will result in a more performant SQL query, because you can basically say to SQL Server, hey, for this time, I need the cell ID. Can you please get me all of the result for that specific cell ID? That is part of the SQL query. If the cell ID in this case is null, it's going to ask for the entire table, which is a bad query, but it's just an example here. Now, another bonus tip that can improve your performance, but more importantly, stability, is DB context pool. Especially if you're having a SQL Server that has a lot of connections from various different applications, or if your application does a lot of connections to the SQL Server. Now, you have multiple advantages with DB context pool. One is it creates a certain amount of DB contexts, and then it starts to recycle them. You're saving up with on startup of the request. It doesn't have to constantly recreate the DB context. And when you finish up processing the request, you also don't have to work as much with garbage collector. But the most important thing here is it recycles the connections to SQL Server, which, in denial of service attack is a big deal. If there's too many connections, SQL Server starts to reject the connections, which sounds a good idea, and it is. But at that stage, SQL Server is so overwhelmed that it's probably not going to be responsive for the next 10 to 60 minutes. So you don't want to get to that point. Even if you cut all of the connections, the way we have done testing in some of the environments, it just wasn't responsive for a long period of time. So DB context pool allows you to avoid those issues. Now, quick note, the DB context needs to be stateless. Try not to put any stateful stuff in it, because it's going to literally use the same one, and it's going to use its internal methods to clean up the DB context. So it's not going to use any of your own methods to do that. There are ways of doing this. That the DB context pool factory if you really, really need it, but I just recommend you to not use stateful DB context at all. Now, the next one is something that I'm quite passionate, is logging. So tag width allows you to basically add a tag, a comment to any of your queries, and that comment is going to be visible in your SQL query. That means if you have a SQL profiler, or you have application insights, or anything that actually is able to get the actual queries that have been executed, you can basically trace back to the code that it called it. Now, in .NET, or in EF Core 2.1 and earlier, you had problems that one query actually translated into multiple queries. And there's actually a way of doing this in EF Core, and sometimes you do this for performance reasons because multiple queries might be faster than one. And when you do .tag width, you can actually see if it's split up into multiple queries. You can then see that it's coming from a singular EF Core query. It basically allows you to track more easily from where all of the stuff is coming from. Another thing that made .NET 6 much easier is bulk processing in chunks. I noticed there's a little bug in there, so if anyone is eagle-eyed, might notice it, but the code, the structure of the code is still correct. So basically what you can do is If you have hundreds of IDs that you want to get from the database, if you're trying to do this in one go, sometimes the database can get stuffed up and it can take really long time to get you all of the results for various different reasons. But what you can do is you can actually chunk them up, those IDs to say 10. That really depends on the performance of the SQL Server. Some more powerful machines might handle more efficiently, say 20 or 30. Some weaker actually prefer 5. It's not exact science as far as I have seen in practice, but 10 is a good number, 10 is a good number to start. And you can get, say, the products for only 10 product IDs at a time. And that not only reduces the stress on SQL Server in one go, but it also allows it to process other stuff in the meantime. So it's not that one query, it bumps it to 100% for 3 seconds, and then it doesn't respond to anything back. It's like it's doing spikes. Small spikes, and it still have enough compute power to deal with other stuff. And sometimes raw SQL is just better. Now, I will say that avoid it as much as you can, because if you use raw SQL, you're losing a lot of good features, like when you do migrations of property names, you lose IntelliSense, you lose a lot of features with this if you use raw queries. But there are cases, especially like update, delete, where you need to do an operation against several different rows, and you want to update them all, for instance, in the same way. You just want to say a where clause update everyone, say everyone that has been employed since, say, 1 year ago, make them active, for instance. So that in EF Core, if you wanted to do, you would actually need to get all of the records, encode, update the properties, and then say do save changes. Now, do save changes is pretty good at figuring out which of the entities has changed which properties, and it's going to update only those. But first off, you need to get first all of the entities from the database. And if that is huge, you might need to chunk it, and you need to start to write a lot of code in order to make it optimum. And then in the end of the day, when you do save changes, it actually does update for each entity individually. Now, it does send it as a one SQL statement with multiple lines, but it does send each individual entity separately. So in that particular case, for instance, if I'm expecting that I need to update hundreds of employees, and this is going to be a frequently used method, you might consider using SQL Server. Just try to reduce it to the minimum and try to separate it in a way where you can easily update it if some other changes coming. For instance, you're changing from SQL Server to Cosmos DB or to Postgres, that you can update that particular code, because this code is no longer going to work in that particular case. All right, so key takeaways. First, do not use IEnumerable. It's almost like you want to download the entire table. Every single time you use IEnumerable and you have link queries anywhere near it, be skeptical about that IEnumerable. In all of the other cases, I strongly recommend IEnumerable, just not this one. Use iQueryable. As node tracking, use it as much as you can. This is almost free performance for read-only queries. Just be careful when you're doing updates on your entities. Sometimes when you do classes, and you're trying to do, say, get sales, and you're trying to optimize it, and then you do that .s not tracking, and then all of a sudden you have a bug that there's one page that doesn't want to update sales. you maybe want to double it up, and one is tracking and the other one is not, so that you avoid that issue. Unfortunately, the APIs does not allow you currently to re-add tracking. So it has only .s node tracking, but it doesn't have .s tracking. My preference would actually be to everything to be non-tracking until I want it to be. But right now it's the reverse. You need to say what doesn't have to be tracking. And I hope you all agree that most of the performance improvements that we did actually made the code a little bit simpler, a little bit more readable, but we gained insane performance improvements, anywhere from two times the performance improvements all to 260 times. And we're not talking about massive changes. In fact, some people say you shouldn't do premature optimization. I would say that in this particular case, it's not premature optimization. It's actually, I wouldn't really say ignorance. That would be a bit harsh. But I would just say it's not following best practices. And I believe we all should follow best practices, especially when you don't sacrifice the code readability. All right, so here we have some of the resources. The GitHub is the first link where you can find all of these examples and a lot more. I went to a lot more details. I've done some images with performance benchmarking on an older PC. I'll try to update them with new PC. I even went to the differences between raw SQL and the differences of link. If you want to squeeze out as much performance as possible, there is also Microsoft resources for better EF core performance. They have really, really good suggestions, and I applied most of these suggestions in my examples. If you don't want to read it, you can just look at my examples. Rules to better entity framework. We have added some rules on SSW rules page. We're adding more and more. Most of the examples that that I have shown are going to be on this page, and also rules to better link, because EF core link is different from link. If you remember, link is mostly for in-memory operations via enumerable, whereas EF core link is using iQueryable, which is used usually for external data sources, not for in-memory. It could be in-memory, but usually it's used for external resources. And now you can scan the code for rewards. For the live audience, I'll come back to this slide a little bit later, so you can snap a picture. I would really appreciate if you give me feedback on the talk, on the whole session. So
There's no way you could scan that
we
with his
know
face
how
on
to
it.
improve, or you can also give compliments. That's also feedback. I'll just wait for a moment. All right. And in summary, I have shown you a little bit what is my machine, how I'm trying to do performance test, and why I'm doing, why I'm wanting to use EF Core, and why I'm recommending people EF Core opposed to all of the other solutions. I have shown you the 7 deadly sins. Show you anyway the enumerable to iQueryable differences, the load testing, and lots of goodies over there, and also some mini best practices that you can just add a line in your code and your project gets magically better. All right, the project you'll be able to find on this link on GitHub, and thank you.
Okay, thank you so much, JK. I can see you put a lot of work into that. Did you build
Weeks
that
of work.
presentation to show off your beefy machine?
Unfortunately, it's not here. It's not my laptop.
Oh, it's not a laptop. It is a big, beefy
No,
machine.
yeah. When I'm working from home, I can show it to you.
Wow, you must get a lot more productivity at home. So tell me, when you have, there's a bunch of questions here on the live chat, but I might just ask, when someone comes to you with performance problems, just generally, I have performance problems, how often does that end up being data related, link or entity framework related?
Ooh. So I'll tell you that in 80 to 90%, I was able to at least get 10 to 40% performance improvement just by looking at the link and doing some tweaks to that. And in about 30 to 50%, I was able to get it 100% or more performance. Stop sharing screen. So like 30 to 50%, over 100% of performance improvements. And almost every single project I have been so far, I had at least one link where I was able to improve the performance by at least 10 times.
Yeah.
Every single project. At least one link.
Okay, all right. Now, how often, when you're dealing with performance problems and you know it's data access, does it end up being something else related to the database, such as you need to add an index here?
Yeah, I think the performance of SQL Server when it comes to indexing and doing relationships properly and EF core becomes so. When you improve the link a lot, you're starting to hit the bottleneck of the SQL Server, and when you optimize the indexes and all of that stuff, the EF core links starts to get the bottleneck. So it's kind of a dance. The more improvements you put on one side, the bigger problem is going to be the other side. So in a lot of cases, you'll need to do more holistic solution, but in most of the cases, just improving your EF core link, or EF core link is just doing SQL queries on SQL Server. So just thinking about how would I do this on SQL Server, and then look at your link and say, is that actually doing what I'm thinking it's doing? Helps, because then you realize, oh wait, I'm actually not doing the thing I wanted to do on SQL Server. You change it, and things get better.
Right. Okay. Cool. I wonder how many people in the audience have had a similar experience to me many years ago, where I've had to turn up to review a client's code base that is drowning, essentially. Things are taking minutes, and they want me to review the entire .NET solution. And I turn up to the client, and they're going, "Oh, the Microsoft expert is here. He's going to fix it." And there's a series of people crowding around. I go, "Oh my God, I don't know what I'm going to do. I bet you I can't do anything." I look at all the code and start looking through, and then I see which page is slow, and then you go to the database and go, "Oh, you don't have an index on this." And you go, "Oh, let's just add an index," and it goes from 2 minutes to a second. And they go, "Oh my God, you're a guru," that type of stuff. And you haven't even need to look at any code. It's just incredible.
Yeah, and that is a very interesting point, because I know really well EF core and how it communicates to SQL Server, but I don't know the guts of SQL Server as well. And we have one coworker here, Bryden. He knows a lot about SQL Server stuff, and I'm like, look, I'm trying to do this query. I'm stuffed. I have done as much as performance as I can get. I got 10 times faster, but it's still not fast enough. And he looks at it, yeah, just add index over here. I add index, and it's like, oh wow, now it's super fast.
Yeah.
And the thing is, in a lot of these particular cases where you have really, really horrendous performance, you need to solve it on both ends. It's not enough to solve it on just one end.
Yeah, that's right. Brighton can suggest indexes before the performance optimizer can. So yes. Tell me, how many times do you come across people that have found a solution which is to execute raw SQL to go outside the entity framework, and they've found that as the fix, and they're just putting that everywhere because they've found that's the answer? Do you ever see that happen?
There were a few clients, very, very few, but it's quite rare because I think they don't want to deal with it. And some just accept the performance and just complain about EF Core. But yeah, in the projects I have been, we occasionally, what we do is say, hey, this query is a huge problem. We have done what we could in EF Core. Are we okay to do it in raw SQL? It's very, very rare. Like in so many projects that we had so far, I think we had 3 queries where we agreed on doing raw SQL for a specific read-only query. So it's exceedingly rare, and sometimes it's the necessary thing.
Right, yeah. Okay. So I'm going to read you a question here. Is there a difference between DocumentDB and relational database performance with bad queries like .tolist, .count? So is there a difference between DocumentDB and relational database performance with bad queries like .tolist, .count?
That is a very interesting question. I'll tell you that on relational databases, absolutely yes. On document side, I have done some performance work on the Cosmos DB, but it wasn't my main focus. We had Brighton working on that part, but we did notice this: if you're using the partition keys incorrectly, you could get much worse performance. That's all I can tell you for now, but hopefully I'll be working more with Cosmos DB on performance stuff more frequently.
Okay. Another question here. Is there an EF Analyzer plugin that you use with your best practices?
Okay, so what I do is for localhost, I use Seek, which is kind of like an application inside, but for your local machine. And I use tag-with, what I have shown in bonus points, where I can tag queries with a very specific tag, and I can then easily find it in my logs. And what Seek allows me to do is actually draw me a graph of whatever I want. And then I can quickly make a graph of different queries based on tags with their performance metrics. And then I can quickly sort out based on which one are the slowest, and sometimes even which one are the least stable. For instance, they have low minimums and high maximums, which suggests that the query itself is optimized, but there are certain cases where they take really long time, and I can then try to handle those maximums.
Rightio. Okay. So this one might require you to share screens and go back to your screenshot of your benchmarks. But the question is, JK, what is the meaning of Gen 0 and Gen 1 in the benchmark.net results?
So that is quite technical. That is basically the garbage collector. Let me go to, I believe is this one. So what happens, so here we have only Gen 0. That means that the memory has been allocated and it's going to be destroyed right away in garbage collector. So that means that the memory hasn't been on memory long enough for garbage collector to push it into a more mature generation where memory that sticks for longer usually ends up, and it's a little bit more performance intensive to clean up more older generations in the memory. Now, if we get to the other one, here. So what we're getting here, for instance, is we're getting, how much is this? So 65 megabytes is constantly being created and dumped right away, whereas 19 megabytes, for instance, kind of lingers in the memory for a little bit longer. And then Gen 2, 2 megabytes, that memory lingers even longer in memory. That suggests that once you get into older generations, that might even be a memory leak for all we can tell, or it might be intentional. But here it looks more like a memory leak to me.
Okay, awesome. Thanks for that. I'm going to finish off, ask you a difficult one. Let's just say you come across someone who loves Dapper and they've used it in the past and they haven't used any framework. What would you say to that person to what to use on their next project?
Well, I can tell them that EF Core 6 is almost as fast as Dapper. At least that's what the claim is. I'm going to probably do a performance benchmark on that at some later date. And I challenge them to try it out and see if that is really true. Because you get a lot of features in EF Core, and if performance is no longer an issue, I would go with EF Core. Okay, so you got me on the performance, but what's a feature in there that you would use to say, hey, come over to the EF world, you'll love this? Okay, so let's start with migrations, then we have SQL temporal tables, then we have we can scan folder database, and then we can do either migrations or whatever you want. We can switch between databases. Do you want to have in-memory database, either in-memory or SQLite? We got you covered. Like, there's so many features in EF Core that is ORM specific, and if for whatever reason, there's a case where it's like, I really want Dapper for this particular case. Dapper can actually hook up to EF Core, and you can use for that one particular case Dapper. So you can put them both together. Yes. So I'm not saying don't use Dapper. What I'm saying is use it when you need it. So if there's a hot path that you need to squeeze out every single bit of performance, sure, use Dapper. But what I have seen, and on GitHub I have done some more advanced testing with, actually executing raw SQL and trying to do my own mapping, my own parsing of the data. You can push EF Core really, really far if you need to. It takes a lot more code for it, and you lose some of the features of it. But you don't actually have to install any additional NuGet packages to try to squeeze as much performance as you can from an ORM. Right, and it's been so many years since we've had to worry about managing database schemas and things like that. So if somebody switched from Dapper to EF, they're going to lose a lot of consulting dollars because they've saved so much time. Yeah, I mean, if you start migrating things, like you add new column or you rename new column and stuff like that, unless you've done really, really good job how you generated the queries. And there's some things that Dapper does that allows you to generate queries more closely to EF Core, and that can help you out, with refactors and stuff like that. But there's still a lot of features that only EF Core has. And I might be wrong, but as far as I remember, Dapper only supports SQL Server. And right now we are in the world where it's like, hey, we want to try Postgres. Would our website work with Postgres? And we have only 3 days to do it. Or, hey, we want to move to Cosmos DB. There's so many different things that can happen. And with EF Core, we're right now at the place where I'm like, 3 days, yeah, that's probably enough to move to a different database engine. It depends on which one. Like, if you move to MySQL, maybe not. But if you're going from SQL Server to Postgres, it's probably doable.
Right. Now, just to finish off, is there any features in any framework that you long for, that you want the team to deliver?
Oh, so one of the biggest thing, and one of the biggest reasons why I still recommend in some cases to do raw SQL is update and delete. We cannot say update all of this, update based on this where clause with these properties. If they can do that, I think they removed most of the need for Dapper. They removed most of the need to use raw SQL, and they also remove a lot of bottlenecks that we have in some of the applications where we need to update a massive amount of data.
Awesome. All right. Well, thank you, JK. Thank you for putting that presentation together. Thank you for putting the rules together. Thank you for helping all the .NET guys and all the SSW guys that have performance problems. It's been wonderful. So hopefully everybody out there will put their comments down. I'm sure you'll answer them. And I will see you in the next one. This is Adam Cogan signing off for SSW TV.